Okay, so today I will go through the solutions for the hands-on exercise that I gave you at the end of the last lecture. So basically, we have a red black tree like this, and then we have to delete the elements 15, 34, and 11 one by one. Okay, so don't watch this video if you have not reviewed the lecture notes and the video of the lecture last time, or if you have not tried this question or hands-on exercise by yourself first. Okay, so as I said, study the concept first, try the work by yourself, and then watch this video so you will say learn much more about how to go step by step following the algorithm you learn. Okay, so let's try to um, go through the solution for this hands-on, and I will start with the 15. Okay, so first we remove the element 15. Now, removing this one, we will simply search from the root, okay, for 15 and remove it. Remember that first we have to locate the element and then remove it. So this node is a black node. So that said, if we remove this one, then the branch here will have one less of the number of black nodes, right? So that said, once we remove this, replace it by a known value, then we have one black nodes count last. So that's why we have to give it a double black count for this one. So you can have, starting from here, one black count, 2, 3. Okay, so it's still the same with the other branches like this, 1, 2, 3. Okay, so first, remove a black node, replace it by a known value with double black count. So now we will try to correct this situation. Okay, so correcting the black count by first looking at the sibling and then the nephews, right? So here we will try to resolve the double black count here by rearranging this subtree since we have the sibling is red. Remember that when the sibling is red, we will try to bring this one or rotate this subtree around the parent here. Okay, so we will try to convert this situation into the following situation. Now, I will try to rewrite this subtree on this board so we will understand it better, okay? So rotating here, we will have 25 up, and then bring 18 down, right? On the left-hand side, we have the double black node, and then 20 will be plugged into the right of 18. And then here we have 30. And when we rotate around this, we will bring the 25 up, and then the red node will be brought to the left branch, right? So that's it. So we will try to bring the red from the right to the left. It's on top of the double black cow note here. So by doing so, you will see that the number of black notes doesn't change on any branches, right? On all branches. Because we bring the red here to the left-hand side, so the number of black cows are the same, right? And on this one, because we brought the red note to the left, okay, it doesn't change here. Same thing for the 20 at the branch through the 20. Okay, so now I will write this one to that part. So after we rotate, we have the following thing. We have 25, and then 18, 30, 20, and remember that the 18 is the red one. Okay, so that's it. After we rotate, we brought the red note to the left-hand side. It's not over yet because we still have the double black count null note here. So we have to do one more thing. But the difference now is that you can see that we have the sibling is black now. Previously, the sibling was red, right? So when we rotate, we have the sibling now is black. Okay. Now, when the sibling is black, we will check the parent, right? So the parent is red, then we can do the arrangement directly. So here, because the parent is red, so if we bring one black cow from the double black note here up, then we can remove the double black cow on this one, right? But if we bring one red cow here, then there will be one more black cow for the branches on the right-hand side. Okay, so that said, if we change this one to black, then we can remove the double black cow here, but we have to reduce the black count on the branches on the right-hand side. We can do that by changing the color of 20 to red, right? So that said, bring the extra black cow up and then reduce the number of black cow on the right-hand side by changing that to red. Then we have a red-black tree, right? Let's try to verify that. Here we have 1, 2, 3. 1, 2, 3. 1, 2, 3. Right? So that's it. We remove the 15. Right? Okay. So that's it. When we remove the 15, we have to do two things, right? First, we rotate left to bring the red note on the left-hand side, and then we rearrange the color. Once we have the sibling is black, and then the parent is red. Okay? So that is the first number. Now the second number, we remove 30. Okay? So again, we search for 30, remove it. So this one is the black note. So again, we have to give the null node one more blackout, meaning we have double blackout here. Okay, now we have to resolve the problem with two blackouts for that null node. So we will try to resolve this problem by looking at the sibling, okay, and the pattern. Remember that previously, if the sibling is black and then the pattern is red, we can rearrange the color. But in this case, we have the sibling is black, pattern is also black. So we have to look for the nephews, right? So one of the nephews is red. Then we will be able to correct the situation, right? So actually, one of the nephew here is red. The only problem we have with this situation is that the red node is not on the leftmost branch, right? So the red nephew has to be on the leftmost or the rightmost branch. If it's not on the leftmost or rightmost branch, then we have to rotate in order to bring it to the left-hand side here, right? So let me write it down on this board. So here we have 18, 20. We will bring this one up, right? So we will have 20 and then 18. And here we have the null node, right? And then here we have the two null nodes, right? Okay. When we rotate this one, we will bring it, bring the red node here to the left-hand side. So that is what we will do here, right? So let me copy this one and plug it here. So we have 20 and then 18. Okay, let's check about the blackout on all branches. Here you have 1, 2, 3, 1, 2, 3, 1, 2, 3. Yeah, it's correct, right? So now we have the situation here. The double blackout node has a black sibling, black parent, and then a red nephew. And the red nephew is on the leftmost, right? So what we will do is that we will try to rotate this tree, right? Like this. Okay. So okay, so what we will do is that we will try to rotate around 25, right? The purpose of that is here we have a double blackout. When we rotate, we will bring one more black node on this branch. So we can say remove the double blackout here. Okay? So let's see what we will have. So we will try to have it here, 20 up. So we have 20. Okay. So I will simply copy this part to the board on the left-hand side here. Okay, so we have 20, and then we have this one 25. Okay, and now we have the double blackout, right? So this one will be plugged into the left hand side of 25. So here we have 18, and then here, right? So here, the difference between this subtree and this subtree is that we bring one more blackout to the right branches. So that said, we can reduce here or remove the additional blackout for this one, right? So let me, and the 18 is red, but we will see what can we do in order to correct the situation. So now let me copy this subtree into this subtree so we can continue. Okay, so now we have 20, and then 18, 25, right? Then we have 2 more years. And here we have this one. Okay. As I said before, when we rotate, we bring one additional black cow or black node to the right hand side. And hence we can remove this one, right? Because this branch will have one more black cow, so it will be used to cancel the double black cow here. Yeah. But when we bring one more, one black node on the right hand side, then the branches on the left hand side will have one less blackout, right? We can correct that situation if we remove this color from red to black, right? Meaning that we add one more blackout for every branches on the left hand side, okay? So now we have a red black tree, and we can verify that 1, 2, 3, 1, 2, 3, 1, 2, 3, right? So we are done with removing the node 30. Okay. All right. The next one is 4. Okay. We need to remove 4. So 4 is here. Remember that 4 is not a leaf node, right? Then what we have to do is that we have to find out what is the predecessor and bring that node up, right? So predecessor, go left, and then on the way right, right? So that said, we will bring 3 up here, and then remove this one. But when we remove this node, it's a red node, so it doesn't change the number of blackout on the branches here. So we don't have to do anything, right? Removing a red node, we can simply remove it because it does not change the blackout of the branches that go through that node, right? So simply have it here. And we can check, right? Number of black nodes, 1, 2, 3, 1, 2, 3. Yeah, we are done, right? So now the next one is 11. We remove 11 is a root. So we have to replace it with the predecessor, right? Left on the way to the right. So we have 8 here. We will bring 8 here. And then remove this node. But this one is a red node, so we cannot simply remove it. We have to give that null node one more blackout, right? So in other words, here we have to give this one a double blackout. Okay? So now when we remove this node, we have to resolve the double blackout situation, right? So again, we have to look for the sibling. Sibling is black, right? So we have to look for the parent. Okay? So the parent here is red. Then we can change something, right? Or in other words, we can try to rearrange the color here a little bit, right? So what will we do is that if this one is red, and if we change this one to black, then the branches here, we have one more blackout, so we can remove this, right? But if we increase the blackout for this one by removing the red, then we have to reduce the number of blackout on this branch. Or, I mean, the branches going to the left here, right? So in other words, here we have 7, and then 5, and then double blackout, right? So if we change this one to from red to black, then we can remove the additional blackout for this node, right? But at the same time, the number of blackouts going through this edge, we have one more blackout. So we can reduce that by giving this node a red, right? So that said, what we will do is exactly here. Just copy this part to this part. So here we change the color, remove the double blackout, change this one to red, right? Okay. So now, what will we have? 1, 2, 3. 1, 2, 3, right? 1, 2, 3. 1, 2, 3. Okay. So everywhere we have the black K is 3. 1, 2, 3. 1, 2, 3. Okay. So that's it. We successfully remove 11. Okay. So keep in mind that when we remove an element, we just have to rotate. Rotate is very simple by, let's say, changing the pointers, right? So if we bring this one up, that means that the parent of this one, instead of 20 here, we have is 8. Okay? Just follow the link and change the parent to 8, right? Bring this one down, meaning that change the parent to 25 now, right? Okay. So changing the parent takes only big O1 time. So any rotation take only big O1, right? So that said, deletion, as I mentioned before, take big O log n because we search for the element, right? It takes the height the hay is big O log M, right? Okay. And then looking for the sibling, looking for the parent, looking for the nephews, do 1 or 2 rotations, right? So the overall cost is big O log N, as we already learned. Okay, so here is the final result. After we remove 15, 30, 4, and 11 from the original tree, okay? And that's it for the red-black tree. So after you watch this video, I hope that you will be able to finish the homework assignment, right? And be prepared for test number 2, right? Okay, so that's it for today. If you have any question, don't hesitate to send me an email, right? I'm willing to help if you have any difficulty in understanding the concept, right? So the algorithm for removing, I already posted, right? For the details, but basically is what I just did for this hand-on exercise. And the algorithm give us 4 cases in that we have to look for the sibling, right? Looking for the parent and then looking for the nephews. All right, so that's it for today. Take care and bye-bye.